Hi students, welcome back. Welcome back to Info for Tamil TV Maths program. I have mentioned in my last class we will be continuing with normal distribution. The next subtopic in that the main topic of normal distribution is standard normal distribution. This is another form of distribution, a standard normal distribution. What is standard normal distribution? Prior to going to standard normal distribution, I just wanted to go through, which is the basic of statistics you must have gone through, coding. Coding is very important part of statistics. But nowadays the coding isn't very important because of the computer program and calculation is so easy. Those days the calculations are not easy. So the coding. So if you have the large the data, the data is the large numbers, you actually make the data into a smaller number, which easy to calculate or easy to manage. So the coding is the two things. One is subtract or addition. Subtract, I would say the subtract will be addition 2. So if you add minus something, it's addition. So subtract or division, subtract and division. So coding, you have a data and then subtract a part of a constant from the data and then divide by another data. Another constant will give you the data is small. Say for example, 1031. It's if you have large data, 1031, 1000 something, it's pretty difficult to sort of act and find a mean and all. So what we do, just to use the coding. So all you do, just to subtract a bigger number to make it a smaller number, and then divide by some number. So I'm going to do, say, 1031. I'm going to take away 1030. So the number would be 1. So easier to manage 1. But you can simply say that how could you actually manage it 1? Then I have to actually use this as an equation to find when you actually come to find the mean or standard deviation, we have to actually put it back into the equation and find the real value or real mean, real standard deviation. But it's just to make it easier to calculate. But just rather than going through what is coding and coding and how we work out, because of I have to go through, that's a basic, I have to go through in GCSE or the A-level first year syllabus, that's different. But I'm going to sort of hit to what we need for the standard normal distribution. The coding for standard normal distribution, we actually studied in our previous class. The mean is mu, the standard deviation, lowercase sigma and all. So I'm going to keep using those values. And again, normal distribution. So let's start a normal distribution. Without thinking anything, normal distribution is this: the bell shape, the symmetrical, and the area under this curve is 1. So if you do that, and we said it before, mu, and then area under the curve is 1, and standard deviation. So if you could write this, x, this is x, correspond, normal. Let me give you this 50, standard deviation 10 again. I used to say this example before. I'll use it again. It'll be easier. So this will be 50, 10 squared. So this is the standard, so not standard, normal distribution. This the curve is normal distribution. This is how you actually represent the curve is x correspond normal distribution 50, 10 squared. But we talked about standard normal distribution. In order to go to standard normal distribution from normal distribution, we have to use coding. What the coding for this particular work is mu, you call it, I'll come to that, z minus, one sec, z equal x minus mu divided by standard deviation. So this is the coding. So you probably ask, what is that is? That is the random variable in standard normal distribution. So x in the normal distribution now becomes z in the standard normal distribution. They call it z value as well. So from x value to z value, how we did it, we actually coded x minus mu divided by standard deviation. So x is any value. It can be 70, 80, 40, 10, whatever value, minus mu divided by standard deviation. It brings you z value or z value. Then having changed that, then we can actually have a standard normal distribution. Same bell shape, but slightly different to the values. That's all. Otherwise, bell shape, maybe slightly squeezed bell shape. Standard normal distribution. Again, like that. Here, when it's a normal standard distribution, it's mu. But what we have now is a coding of is x minus mu or sigma. So if I could actually write it here, this is, say, it started with mu. But what this one, I'm going to convert this one into. So this is the actual x value at this particular point. It's x value here is something, something, something. And when you come to here, x value is mu, and then more value, more value, more value. So just to start with, so x value is mu. So the coding, what the coding says, x minus mu divided by standard deviation. So x is mu here. So mu, then again minus mu, standard deviation. Mu minus mu, standard deviation, which is 0. So, from the normal standard deviation is normal distribution to standard normal distribution, the mu become 0. So mu is 0. Mu, straight away, the standard normal distribution, mu is 0 by coding. And then standard here, this is, say, for example, 1 standard deviation, which is what? Mu minus sigma. So if that is the x value at this particular point, which is 1 standard deviation left-hand side. If you go to the other side, 1 standard deviation right-hand side, right? Then we use, this is the normal distribution value or x value. This is x value. We need to use the coding. So for this one, that would be x. X is mu minus standard deviation. And then another takeaway mu divided by standard deviation. So what will be minus 1. Similarly, this side is plus 1. Now we can actually come to a conclusion. When it comes to standard deviation, the mu is 0, standard deviation 1. Regardless of what the actual mu, actual standard deviation, this one always valid. The mu is 0, sigma is 1. But that's, of course, we need to remember the coding all the time, because otherwise we actually take away from the normal distribution or the normal data. So what we are doing, normal distribution to standard normal distribution. Then when you come to standard normal distribution, the mu is 0, sigma is 1. In order for some calculation, you can ask the question, why is it 4? It's for some calculation because of this is the known value. So what are the known value for this particular case? It's 0, 1. If you have another question, yes, 0 and 1. But the coding will be different, different question or different data. So always standard normal distribution, the mean is 0, standard deviation is 1. So we know some value for us to calculate certain calculation easier. If you have a data normal distribution, this graph is, you should draw this without even thinking of that. This is always normal distribution. The mu and then standard deviation. So this is how you represent this graph, is always if this is x. It can be x, it can be z, it can be y, whatever. Yeah, but I'm just taking it as s. S relate to n is a normal distribution. 50, I'll write it 50 again, 50, 10 squared. So this is the normal distribution. But now I have convert this, so I wanted to convert this into the standard normal distribution. So standard normal distribution, again, this one is z value, we said it. And this one, of course, this is a standard normal distribution. The shape of the graph is different, but it's still bell shape, it's still symmetrical. The area under the curve is still 1. So here, the mu, inside of mu, we know mu is 0. We know without thinking of the mu is 0. Standard deviation is 1. So how you represent this? Z instead of x, z, because of the z value. Z relate, normal distribution, of course. It's a standard normal distribution. It's a normal distribution. Instead of 50, we put 0, because of that is what it is. And then instead of 10, 1 squared, because of here, the standard normal distribution, standard deviation is 1, mu is 0. Mu is 0. The coding, always same. What is it? This is x minus mu. That. Yeah, if it's x, whichever value. So, for example, x is here, 70. So x is 70 minus 50, we know the mu, divided by standard deviation 10, give you z value. What are the z value for that? It can't be this. This is z equal 70 minus 50 divided by 10. That is equal to 2. Yeah. So in other words, 2 is standard deviation. 2 standard deviation, the right-hand side. So if you want to find out the area, it's easy to find out. As I said before in my previous class, the 2 standard deviation and 2 standard deviation, between that 2 is 95%. So that means if that 2 standard deviation, 95%, what left with is 5%, isn't it? Say the 100% altogether. So left with 5%. So this bit is 2.5%. In this side, 2.5%. 2.5%. This is 95%, another 2.5%, add them all together, 100%, that's what it is. So if I have this value, what is this side? This is 2.5%, what is this side would be? Yes, it's 100 minus 2.5, so 97.5%, this side of it. So what I'm saying is that there are ways to do some calculations. That's what we are doing it. So standard normal distribution, what we know is the mu, what we know, the standard deviation. Straight away, mu is 0, standard deviation 1. So for this particular thing, sometimes they ask you to find mu. They ask you to find standard deviation. For the normal, if you have the data in the normal distribution, you cannot do that. The calculator wouldn't give you the value. But you need to go into another way to find it. So this is the standard normal distribution. In case of you don't know mu, you don't know standard deviation. All you do, just coding it, then you go into standard deviation is 1, mu is 0. You can find the value. Let's do some questions on this. Let me try a question. All right, that's a z value. So standard normal distribution curve, this is 0. And you denote that z relate to normal distribution 0, 1 square. That's it. So if you see somewhere this, that you straight away know it is standard normal distribution. Say, for example, you have a value is a, the z value a. How you write it in the form, you always write is x. Say if you can simply ask a question, why is it x? You were talking about z and why is it x? I just wanted to, this is the normal distribution. This is if they ask you to find this, a less that. Or if you wanted to relate to this one, p, a less than z. So z is less than a. What they ask you to find a, you can actually find a because of when you come to z, you know the standard deviation, you know the mu, then you can find a easily. When you actually write this one, there is another way of writing this. Another way of writing this. How you write it is like that. This is a format you write. Is a. This is how you do it. This is the what this one is. The probability less than when z is less than a. When z is less than a, that's the probability. How you write it in another way of doing it, this is normally in your exam question, they probably have this. Anything less than that, you write it. Say, for example, if you have probability z greater than a, right? Z greater than a. You want to write it this way, but you cannot do that. It has to be less. This wouldn't do it. So what this one is, this one is left-hand side of the A line, and this one is the right-hand side of the A line. So can I say that the left-hand side of the A1, 1 minus right-hand side of the A1, or right-hand side of the A1 is 1 minus left-hand side of the A1. That's what it is, isn't it? So I can write this one equal 1 minus P A Z simply. All I'm doing it. What this one says, that side, that bit. But I can't write this format for greater sign. So I need to make it as a less than sign. This one is, the whole thing is 1. So this one is 1 minus less than sign. Then you can write 1 minus a. Simple as that. So z greater than a can be written as 1 minus this format. It's normally, why I'm writing this, normally the exam, they probably give you this. So you need to know always that one is less than a particular value. The z is less than particular value. If you ask you to find the greater than, then you remember you need to do 1 minus the value. Another question, say example. Normal distribution. They have given this one, x, relate, normal distribution, let me do mu, and 3 squared. So what they have given, or what they haven't given, is the mu. So you don't know mu. But the standard deviation is 3. As I said, when you use a calculator, and you cannot use it with this unknown value. So you need to do it standard normal distribution. They said, this is z equal, this is mu equal 0. This is going z. Let me write it x again. So mu is, this is mu, this is x. Standard deviation is 3. Right? The question is to find x, say, is 20, greater than 20. So the question is to find p x greater than 20 to find. That is equal, is given 0.20. Right. So what this one says, if you look at this is your normal distribution, the normal distribution. I haven't actually changed it into standard distribution. There's a normal distribution. That's 20 is the value when x is 20. and the probability greater than 20 is given as 0.2. So in other words, this side of the graph, this anything right-hand side of the 20 is 0.2. So this bit is 0.2 or 20%. 20%. They ask you by here, if it says this is 20, this is given, so we can use a simple inverse format. No, we can't use it because we don't know mu. So all we need to do, we need to convert that into a normal standard distribution. Only thing we know is the coding. So how you do it, you can write this as x greater 20 minus mu divided by standard deviation. That's the normal, always x minus mu. That's what we said here. The coding is the coding. X minus mu over standard deviation. That is exactly what I'm doing. X minus mu over standard deviation. Mu we don't know. This one, 3, we know that. This is equal 0.20. When you come to calculate the standard deviation, I have mentioned to you is always we need to convert into the form less than, whatever you have, less than. Is it confusing? This less than. So let's write this. How you write it? Always x greater than 20 minus mu over standard deviation equal 1 minus, if this side, that is, the whole thing is 1, instead of representing this one, I'm going to represent the whole is 1 minus the left-hand side. So the 1 minus p x less than 20 minus mu over standard deviation. Simple as that. This is what we need to convert to in order to use a calculator. So if with that, as I said before, you cannot do that, cannot achieve it. Otherwise, it's pretty simple. You can get the inverse and do it fine. But you need to use it this way. So we can find this value. So let's look at the calculator, how we can manage that. Again, so we can write this minus that, isn't it? Because of when you have the less than, you can actually write it as 20 minus mu divided by delta. Standard deviation, sigma. We can find the value for that. The whole value, the whole of this is 0.2 because of this is equal this is equal that. We write it this one. So the whole of this value is 0.2. So if I could actually write again 1 minus that 20 minus mu sigma equal 0.2. So what is this one would be? If we could take that to the other side. So sigma, the sign of this is 20 minus mu divided by sigma equal 1 minus 0.2, that is equal 0.8. So now we come to this form. I'll rewrite it. Equal 0.8. Standard deviation is 3, so I just wrote it here. This is the standard normal distribution format in order for us to calculate and find mu. This is the format. There's the area given. There's the function we need to find. So if I use the calculator for inverse function, let me select the normal distribution, and I need to find the option for inverse. The area is 0.8. The standard deviation is 1, and the mu is 0. The answer is 0.842. 0.84. So for that, so 20 minus mu divided by 3 equal 0.84. If I could rearrange it, 20 minus mu equal 2.52. Mu equal 20 minus 2.52. That is equal 17.48. So we have found mu. So in order to find mu, this is how we have to do. We have to actually convert the normal distribution into standard normal distribution, then use the usual calculation method to find mu. Thank you.